everyone, I'm Francisco Verga from BSCS2B. So in this video, I'm going to show you and explain to you my Python program. So it implements a queue abstract data structure using a linked list implementation. So first, what is queue? It's a collection of entities that are maintained in a sequence and can be modified by the addition of entities at one end sequence and the removal of entities from the other end of the sequence. By convention, the end of the sequence at which elements are added is called the back, tail, or rear of the queue. And the end at which elements are removed is called the head or front of the queue. So imagine a line at a coffee shop. People join the back and the person at the front gets served first. That's the essence of queue in computer science. So it's a data structure where elements are added at the end and removed from the beginning. So just like a real-world queue, tasks are processed in order arrive. So ensuring fairness and organization. So queue are incredibly useful in various programming applications, from handling website traffic to managing tasks in operating systems. So if you're interested in learning how to build efficient and organized systems, understanding queues is a crucial step. So I'm going to show you first the Python program. So let's get started. This code defines two classes, node and queue, and provide mechanism to manage multiple queues and perform in-queue and dequeue operations on them based on workload values. The node class represents a single node in a linked list. Each node contains a data attribute to store with a value, and a next attribute to point the next node in the list. The init method initializes a node with the given data value. So in queue class, the queue class represents a queue data structure using linked list nodes. It has attributes front and rear pointing to the front and near nodes of queue, respectively, and total workload to store the sum of all workloads in the queue. The init method initializes an empty queue with front, rear set to none and total workload set to 0. So the isEmpty method checks if the queue is empty. enqueue method adds a new node with a given workload to the rear of the queue, updating the rear pointer and total workload. The queue method removes and returns the workload value from the front of the queue, updating the front pointer and total workload. Display method prints the workloads in a queue along with the queue number. Traverse method is a generator that yields each node in the queue. So get minimum workload queue function. So this function takes a list of queue as input and returns the queue number with the minimum total workload among them. So it creates 3 queues and enter a loop interact with user. It displays the workload in each queue and provides option to enqueue a workload, dequeue a workload, or exit the program. If the user chooses to enqueue, it calculates the queue with the minimum total workload and adds that workload to the queue. If the user chooses to dequeue, it finds the workload with the minimum value across all non-empty queues and dequeues it from the corresponding queue. The code manages multiple queues and ensures the workloads are added to the queue with the least total workloads. Dequeuing removes the workload with the minimum value from all non-empty queues. It provides a simple interactive interface for user to enqueue and dequeue workloads efficiently. So I'm going to show you how my Python program works. 3 queue objects are created and stored in the queue list. Each queue object has attributes for front, rear, and total workload. We will put an workload in each queue. So we have 3 choices here: 0 for exit, 1 for enqueue, and 2 for dequeue. To enqueue an element or workload, just choose one. So workload 3 has been enqueued at Q1, workload 5 has been enqueued at Q2, and workload 2 has been enqueued in Q3. Since all queue has been filled of workload, The next workload will be in queue at the least total workload. It calculates the queue with the minimum total workload and adds the workload to that queue. So as you can see, the total workload of Q1 is 3, Q2 is 5, and Q3 is 2. The smallest value among the 3Q is Q3 because it has a value of 2. So kapag tayo nag-add or in queue ng isa pang element, it will place at Q3. So workload 1 has been in queue at Q3. After we in queue the fourth workload, the least total workload is Q1. Because the total workload is of Q1 is 3, Q2 is 5, and Q3 is 3. So as you can see, mas magkapareho ang value ng Q1 and Q3. Pero i-consider niya na ang Q1 ang may least total workload dahil nauuna ang Q1 sa Q3. So the fifth workload that we will in queue is inserted at Q1. So workload 4 has been in queue at Q1. So now the total workload of Q1 is 7, Q2 is 5, and Q3 is 3. So the least total workload is Q3 because it has value of 3. So the sixth workload will be placed at Q3. So workload 2 has been in queue at Q3. So now the total workload of Q1 is 7, Q2 is 5, and Q3 is 5. So katulad kanina, magkapareho ang total ng Q2 and Q3. So, pero i-consider niya na ang Q2 ang may least total workload dahil nauuna siya sa 3. So if we in queue another element, it will be placed at Q2. So workload 6 has been in queue at Q2. So, press 2 to dequeue an workload in each queue. It dequeued the workload with the minimum value across all non-empty queues and dequeues it from the queue. Since queue is a first in first out principle, the first workload you in queue that also be the first workload you will dequeue. To dequeue, it will compare all front of each queue and it will search a queue that have a least workload in front. So the front of Q1 is 3, Q2 is 5, and Q3 is 2. Since Q3 have a least front, it will dequeue at Q3. So 2 will be removed. So now the front of Q1 is 3, Q2 is 5, and Q3 is 1. So Q3 pa din ang may least front. So it will dequeue at Q3. So 1 will be removed. The front of Q1 is 3, Q2 is 5, and Q3 is 2. Q3 pa din ang may least front. So it will dequeue at Q3. So 2 will be removed. So since Q3 is empty, it will compare at Q1 and Q2 only. So the front of Q1 is 3, Q2 is 5. So since Q1 has a least front, it will dequeue at Q1. So 3 will be removed. So next is the front of Q1 is 4, Q2 is 5. So the least front is at Q1. So it will dequeue at Q1. So 4 will be removed. Since Q1 and Q3 are empty, it will dequeue only at Q2. 5 is the least front of Q2. So it will remove because 5 is in the front. And 6 is the 6 is natira na lang na element. So 6 will be removed. So 6 will be removed 2. So if you choose 0, it will be exit, and that will be the end of the program.